Agenda for today. We will first have an intro and then we will learn more about the Shift2Rail technologies such as intelligent video gate, freight propulsion concepts by Andrea Mazone, and then control of railway yard by Magnus Wahlborg, and then Arne Henning will tell us a bit more about new wagon concepts. And then in the end we will have a summary and then the Q&A session at 10. So, starting from the beginning. First we had Shift2Rail. It was a partnership formed in 2014, and it was focused on research and development to create an attractive, sustainable and competitive rail system in Europe. But since November 2021, this partnership transformed into Eurosrail joint undertaking, and it is building on the achievements of the Shift2Rail. In addition to this, we have the European DAC delivery program, and it was formed to achieve a successful implementation of the digital automatic coupler for European rail freight. And the Shift2Rail program has inspired this program then in order to focus more on this important technology, which was seen as an enabler for several additional technologies. So, therefore, this seminar series will today focus on the Shift2Rail learnings. What was the results from the Shift2Rail partnership? And then the second one, next week, we'll have a Eurosrail outlook and what will happen in the next partnership and what will be the focus then. And then in the third seminar, we will look more deeper into the technology and the possibilities with the digital automatic coupler. And these seminars will have a freight focus, and within Shift2Rail, the focus on freight was within the Innovation Program 5, called Technologies for Sustainable and Attractive European Rail Freight. So, Anders, can you describe a little bit what we looked into in this Innovation Program 5 and what was the results?
Well, the first thing that we have to mention is that we, in IP5, we started to share a common vision for what we wanted to achieve. And it's a lot about automation and digitalization. And this is a picture just to remind us what the focus on the topics are. We have another picture later here. Then you can see more in detail what we are looking into. And if you look at the train, you can see that there's a lot of aspects on the train here. We are, for instance, have had a lot of effort to improve the condition-based maintenance, seeking to identify maintenance problems before they become a risk in the transport. The CDAS, connected DAS, is about the driver assistance system, and it's a step forward also to the automation of the whole train. The coupler, of course, we will tell about that more in third seminar, yes. And then we also have looked into the wagon design, and Arne will tell you more about that. And we have looked into how to improve the locomotive for freight. And that is Andrea, who will tell us about that. We also have some timetable planning and operational planning, how to improve the efficiency and punctuality in the freight system. And that is Magnus' business. He will tell you about that. And in the end also we just had worked on the migration plan to see how all these technologies could be implemented in the coming future.
Yeah, thank you, Anders. And of course, these technologies, we have looked into them, but we have also tested them in the real environment. And for example, we've had demonstrations in Sweden for the digital automatic coupler. And we have tested this coupler if it functions also well in the winter conditions. And that's been in the northern Sweden, I think between Umeå, Luleå, around there.
Yes, it was.
And we've also tested these longer trains, and in 2021 we had a test train with a length 832 meters running from Mazone in Germany to Malmö in Sweden. And in 2022, we already also had a test of an 835 meter long train between Mazone and Fredericia in Denmark. But it's also planned to have a test for an even longer train, which will be about 1,050 meter long during this year. And right now, the train length of the train is about what in Sweden?
Well, in Sweden it's about 630 meter in general, and we of course there are some trains that are longer, but not so many.
So this will definitely affect the capacity of the trains. And there's also been a demonstration of the intelligent video gate, and this is an intelligent video gate just outside of Lindholmen Science Park in Gothenburg, actually. So now looking into the agenda again, we will start by looking into a video about the intelligent video gate. And then we will continue with the results that Andrea, Mazone, Magnus, Wahlborg and Arne Henning will describe more about. But then starting with the video. Shift2Rail is the first European rail initiative to seek focused research and innovation and market-driven solutions. Shift2Rail promotes the competitiveness of the European rail industry and meets changing European transport needs. To take us one step closer to the modern and more competitive railway, an intelligent video gate, an IVG, has been developed within the program. The train runs through the gate, and the gate can collect data with the help of camera images and optical readers supplemented with information from barcode scanners. By implementing the IVG, automated and digitized real-time information can be created for several operations that today take place manually. The gate can detect wagon numbers and unit numbers, train composition, identification of dangerous goods placards and UN number, as well as detection of wagon damage. This information can then be used in management systems at terminals and data sharing with stakeholders in the multimodal chain. The project Freight Rail 3 within Shift2Rail demonstrates and analyzes functionalities for two intelligent video gates, one in Nürnberg in Germany and one in Gothenburg in Sweden. The one in Germany focuses on identification of damages, and the one in Sweden focuses on data sharing between actors. The IVG in Nürnberg is located by the shunting yard. The focus is to train an AI program that can identify wagon damage automatically. This process will enable an improved damage management of wagons and load carriers, as well as a more efficient use of shunting yard, as a damaged wagon is automatically identified by the IVG. Another IVG was built during 2021, here between Gothenburg Port and Kville Railway Yard. I'm sitting here with Jan Bergstrand, Senior Strategist at Trafikverket, the Swedish Transport Administration. So Jan, why is it important to try new technologies from Shift2Rail in Sweden?
Yeah, the main reason is of course that Trafikverket and with partners spending a lot of efforts and money as a founding member in Shift2Rail. So in the light of that investment and to build up competence further here in exchange with our European partners, it's important to have a window towards the Scandinavian market as well. And of course we have sometimes also special conditions with regards to weather. We have sometimes, at least even in Gothenburg, winter, and that's important to test the technology also in such conditions. So that's a couple of reasons for why we are active. We have also good support, I think, from the governmental side to do demonstrations, etc. Sweden want to take a position in being a demo arena for new technologies, so that goes also very well in line with that objective.
The test with the IVG here in Gothenburg will focus on intermodal freight transport between the railway and the port. To enable useful functionalities, the interface has been developed to analyze the information received from the gate. Automated and digitized processes in the intermodal freight transport contribute to increased utility and quality. For example, by improving management of deviations, increasing quality of information and information security, optimizing transshipment, contributing to more precise times of departure, increasing the operational efficiency, and enabling information sharing between concerned actors. How do you at the Swedish Transport Administration see the possibilities with the IVG?
Yes, the IVG, Intelligent Video Gate, is a great innovation thanks to a number of things, mainly because it's affordable, but also very suitable in corridors and in terminals and when you cross borders. So it's a great value for a relatively limited money and investment. It can also give very good, and this is the main point with innovation, possibilities for good planning. We capture data, the wagon and the unit, and we can also detect wear and tear. But the main, and that's quite common, but the positive thing is also that we can detect identification numbers both on units and wagons, and we can also detect, as we use optics and RFID in combination, we can detect also placards like dangerous cargo placards that is not always placed at the same spots. So it gives openings for very good terminal planning. That's the main reasons for why this is so interesting.
I'm standing here with Malin Collin, Deputy CEO of Gothenburg Port. An important part with the tests in Gothenburg is to analyze how the information exchange can be improved with the help of the IVG. Why do you think it's important to be a part of this initiative?
We as a port would like to have a broad cooperation with parties that like to share data and invest in digitalization. We think it's a good initiative where we can have mutual collaboration with the data and improve and use modern technique to help the port to be more efficient.
In what ways can the IVG create better conditions for the work in the Gothenburg port and vice versa?
You can get better predictability and more reliability, and early data will increase the possibility to plan and customize the planning for our partners. And we think that we'll be able to increase work environment and reduce emissions and get more efficient. And in the ending, we will have a more sustainable smart port.
By building an intelligent video gate here in Gothenburg, we can gather experience that can lead to greater development with more gates and increased data sharing between stakeholders. What do you think about the further development with the other ongoing technologies within Shift2Rail?
Intelligent Video Gate is a part of itself, but also in a larger scale and systematic approach. And first of all, it's suitable to, as mentioned, implementing corridors. So we have started a dialogue with Scanmed and other European corridors. That's one arena for further development, but also further functions is related much to digital automated coupler, which is also demonstrated here in Sweden and in Europe, and that belongs to the automation of railway system. And with the camera, optics and RFID, you can, for instance, support automated train operation with inspections and startup processes for train, which is today very manual and time consuming.
Now it will be interesting to follow and see the development of the IVG together with the other Shift2Rail technologies. And we look forward to the successor of Shift2Rail, Europe's rail. So that was a little bit about the technology Intelligent Video Gate and the possibilities with the technology. And now we will move on and listen to Andrea Mazone from Alstom and his results when he looked into the locomotive of the future and the new freight propulsion concepts.
Good morning. This is Andrea Mazone. Hear me?
Yes.
Hi. It's a pleasure to be here. Good morning to all of you, and to be able to talk a little bit about new freight propulsion concepts, what we have been doing in Shift2Rail. I've been coordinating myself two projects, FFL4E and FreightRail 2, where some of the technologies that I will present have been developed or are still being developed. I think let me start with the IP vision, as Anders has already introduced it shortly. I will not go into the details. I just want to show that within this picture we have been focusing from a technical demonstrator perspective on new freight propulsion concepts. What does it mean? We have been looking at how can we make propulsion more efficient, how can we make it more powerful, how can we make it more reliable. We have been looking at different things, at hybridization of shunting locomotive, hybridization of dual mode locomotive, the development of last mile applications, and also for instance, power peak shaving concepts to make the traction more efficient, and also on long trains that we already heard at the very beginning. And I would like to focus in my presentation on the two of these areas that we have been working on last mile, because it's very interesting for the freight operation as such, and the long train activities. So let me start with last mile very quickly. What is last mile, or what is the last mile concept? I think as much as we know, Bombardier Transportation was the first company introducing in 2011 this concept of having a last mile propulsion for mainline locomotives. What does it mean? Mainline locomotives, usually electric locomotives that run under catenary, the modern ones, was equipped with smaller energy source. In that case, it was a diesel engine with together with a booster battery, allowing the mainline locomotive, the electric mainline locomotive, to enter a non-electrified line, a shunting yard, a port. By doing so, the operators were gaining flexibility, were gaining independence from the shunting services available in those specific locations. While in some cases, there is no real shunting service available, and therefore such a technology allows to create new businesses as such. We soon realized that the diesel engine is nice to have, but customers were looking for CO2 neutral solutions for different reasons. One reason is that they wanted to enter into closed areas, into garages, into mines, into areas with dangerous goods. and so a diesel engine would not have been ideal for that. On the other side, you know that from a political perspective, everything is looking towards a CO2 neutral operation, and this is why we started very early with the first project with FFL4E to study the replacement of the diesel engine with a battery. Various use cases were analyzed, many of them also in Sweden, to look what does last mile mean? Is it just 1 mile? Is it 10 miles? Is it 15 miles? Are there steep gradients usually, or is it usually flat, like in a harbor or in a yard? What is the energy? What is the energy need of such a propulsion concept, and what the power? And the first prototype was developed. Freight Hub continued to work on this activity by now enlarging a little bit the scope, looking at different energy sources like fuel cells application, or with flywheels, or with supercaps, still keeping in mind the use cases analyzed in FFL4E, and still also considering the available space on a locomotive. Because it's you can do whatever you want, but if you need to integrate it in an available space, which is often very limited, it starts to get challenging. And on the right side, by the way, you see also some first concepts how such batteries could be integrated. Then Freight Rail 2 took the results out of Freight Hub, which indicated that battery would be the most suited solution, being independent from the infrastructure. For instance, compared to fuel cell, where you need to be able to find hydrogen, and not all shunting arrows or ports would have the infrastructure ready. So batteries seem to be the more interesting or the more suitable concept, and this is why Freight Rail 2 started to develop the one last mile application for mainland locomotives. Here, how this would look like. You see the locomotive, you see the green area that will be used by the last mile battery. You see on the right side also some technical results. What will be the capacity needed to do shunting applications, last mile applications, so 250 kilowatt hours to 400 kilowatt hours, and powers above 300 kilowatt. And this is very challenging, especially with respect to the energy amount that needs to be integrated with the weight and the price of such batteries. And this is what is being developed now within Freight Rail 2. You see that we fulfill the power requirements with the capacity. We're still not there. But unfortunately, on the locomotive, there is not enough place, not yet. So we need to wait for, I guess, for next generation of batteries to be then really able to fulfill all the complete set of use cases and requirements. This is how it looks like today. So you have a cubicle with the battery modules at the bottom, the power electronics in the green part. As you can see, it's quite a large cubicle that needs to be integrated in a locomotive. Of course, last mile works only if you have a powerful energy management system. We call it mission management because it goes even beyond standard energy management. With last mile application that has such a limited energy content, you need to really know where the point of no return is. So the driver really needs to understand the actual situation, not only the state of charge of the battery, but also do we have strong headwinds. For instance, in certain port areas, strong headwinds have been proven to increase significantly the consumption of diesel in today's applications, or also electric energy. And that's why it's important to take care about all the possible factors, and then to calculate or provide to the driver the best information, how to drive and how to perform its mission. Now, let me go to the other focus area, which is long trains. And this picture shows how the competition has been working in the last years. And you see that on water, the quantity of goods being transported has increased massively, on road as well, on rail, not really. And one idea to improve that is, and this has been stated also in the multi-annual action plan of Shift2Rail, is to increase the train length increase, but also the train weight that can be propelled by having distributed power in a train. What are the key topics there? Safety management, of course, within the train. If the train becomes longer, you need to make sure that the forces, the longitudinal forces, do not become too big, that you need to have that under control. This has been analyzed. Of course, the technology has been developed, and the teams have been looking at how or what needs to be done on the infrastructure side, and how can a migration look like. And this is what a draft of the different use cases. You see the status quo at the very top, where you have for heavy trains or longer trains, usual double traction in the front of the train. And the first development and demonstration was to split that and to have a sandwich operation, as we call it. So one locomotive at the back of the train that pushes. And then in Freight Rail 2, we started to increase the capability of this system, introducing communication over LTE, allowing more than 2 locomotives in a train. And as Anna already mentioned, we also had a demonstration with longer train. And of course, the short term is what I show at the bottom, where you need to apply many changes also on the infrastructure, and this will be a long-term activity. Here's some a little bit more information on the different demonstrations. So you see quite heavy trains we have been propelling and demonstrating, also on steep gradients with with mixed wagons, so different single wagon loads. And then here the ones with the 835 meter train, and the results are very, very promising. You see here that we could show that by having this technology, not for the very long trains, but standard train lengths, but distributed power in the train, not only the train length can be increased, but also the tonnage. And every single point here is a train. So this has been really measured by Deutsche Bahn, who was partnering here. And you can see that there was a shift from left to right to the top, so towards longer and heavier trains. And this shows that the productivity can be increased and must also be increased. This is how it looks like. So different components in the locomotive. So there is a brake panel, of course, the radio module, and then the communication system. Now let me show you a movie before ending the project, the presentation.
One train, 3 locomotives, 2 controlled remotely by the leading loco. It's all made possible by a distributed power system. How is this different from traditional double-heading? Distributed power allows for much heavier and longer trains, in the future up to 1,500 meters long. Short trains are linked together to create one long train. They travel their common routes as a platoon on rail. These platoons make rail freight transport more efficient and more competitive, and add transport capacity to the rail system. DB Cargo, Bombardier and Faiveley have been developing and testing distributed power with additional partners as part of the EU's Shift2Rail initiative since 2017. In February 2021, a train composed of mixed wagon types and different load levels has been tested with the latest distributed power prototype. The aim is to use the system for single wagon load as well as block train and combined transport. Over 7 days and nearly 2,000 kilometers, covering various environments from rural to urban and from flat to hilly, the system has been tested in all relevant driving and braking scenarios. The system passed with flying colors. Radio interruptions played a minor role. Braking was smooth and energy efficient. Brake releases and restarts were fast, and there were large traction reserves on acceleration. Distributed power is set to play a major role in making rail freight transport more competitive and in shifting more traffic to rail.
Okay, now I'm at the end with the technical presentation. Some learnings, I think, which personally I believe are very important. First of all, the gap between the results achieved in such projects, collaborative projects, and the product, and then a final product ready for commercial operation remains large. The development of these technologies require much more time than expected. Further investments are required for the successful dissemination. and the framework usually often is not really clear, because we have been working in collaboration in a collaborative way, and then you need to deal with IP rights, and you need to deal with new customers that may be interested in your technology, and this is something that is very important and also challenging. But I must say, the setup is also very interesting, because for many products and technologies, there is no way around collaboration. We need to work together. We need to develop that together with the competitors, together with the customers in the whole vertical. The specifications must be done and aligned among us. And we need the infrastructure also to test. Technologies like long trains cannot be tested on a yard. They cannot be tested on a test ring. You need really to go into commercial operation and to test it in the real environment. And this is also then at the end, I think Shift2Rail gives the framework to follow and to look at these ambition visions, to work on these on the technology that will fulfill the vision, and I'm confident that also with Europe's rail this will continue like that, and we will see more and more results coming up. Shift2Rail started as a first, but we'll see now slowly the first results being introduced in the market, and I'm looking forward also to the following activities and research activities. Thank you a lot. That was all from my side.
Thank you, Andrea, for a very interesting presentation. We have we have one question for you from the audience, and it's when do you think these smaller size batteries can be on the market?
Well, I would say from in 1 to 2 years from now on, we will see first applications, last mile application based on batteries. I mean, the question, I understand the question, it's a good question, because a lot of people say, well, where is the challenge? I mean, there are already battery trains running on the European network, right? There are full cells trains running on the network. Why is a last mile battery so complex? And that's because of the limited space, the limited weight availability that is there, and still the request for a lot of energy, because of course a freight train may be very heavy. The use cases can, a locomotive can run alone, but it can also propel a 750-meter long train, 3,200 ton, and the battery needs to fulfill all these requirements, and that's the difficulty. It's more I would say an integrational topic, and the readiness of the battery itself, the battery technology, to allow the integration into the market.
Yeah. Okay, thank you. I think we will take more questions in the Q&A session at 10. But now we will, thank you, and now we will move on to the presentation about the control of the railway yard and Magnus Wahlborg.
Yes, can you hear me?
Yes.
Very good, thank you. So I then will share my screen. So, yeah, my name is Magnus Wahlborg and work at Trafikverket, and I will describe this Shift2Rail yard and the network management, and I will in some way focus on demonstrations in Sweden. And in Sweden, I am also a Trafikverket contact person for the research program KITE, and also in project lead of flagship 1 in Europe Rail. Trafikverket is co-leader with the Siemens of flagship 1 traffic control. But this is yard and network management in Shift2Rail, and in this IP 5.2, we have had 6 projects, and now we are in the number 7, Freight Rail 3. And as the PowerPoint picture to the right shows the concept that we developed, and that was a sending yard, the line between yards, and then receiving yard. And we have done research in this, and this was then led from Trafikverket and DB. In the beginning it was DB, and then together with Trafikverket, and then Trafikverket become the most active. And we also have involved Green Cargo in some activities, though they have not been an active partner in the project. We have had system suppliers involved in this, DXC, Indra, and Simcon, and for the Swedish demonstrators, especially Indra, a system supplier from Spain. And Academia, the Kite Group Sweden, from France, IFSTAR, University of Rome, and so on. And in the beginning, it was very much with this Sweden, Germany, Czech, Italy, and doing these demonstrations and having a wider scopes with many organizations and many countries. And the later part in project 6 and 7, then we have a focus on demonstration in Sweden. And of these demonstrations, we have numbers of them, but I will focus on the yard part of this. So the first project we had was this ARC project from 2016 until December 2019. And in this project, we started also to look at the roles at yard, the infrastructure manager role, yard manager, operator role. We were also coming into this with connected terminals to yards. And then we are coming to this with freight train operators, with RU Freight and their role, how they are connected to this. And in some way we are coming to freight customers, though the main focus has been with IM, yard manager, terminal manager, and RU Freight. And we started with, in Sweden, with ARC to the upper right. To the left you have inbound, and then you have the marshalling part, and then to the right the outbound. And for Hallsberg, it's the biggest marshalling yard, and we have a good capacity in Hallsberg and so on. But what we were looking at was the processes, and also identified what kind of are the problems and how can these be solved, but by improved information and improved decision support. And then we mapped these identified problems when we have made these studies at Hallsberg, and then to the right with the new information, how these can help to improve the processes. And there we also come to this, that data sharing and cooperative planning for yards is really helpful. When we started in ARC, we had the focus Hallsberg, Malmö, but then project after project, we have widened the scope. And also we realized that Malmö is much more a bottleneck compared to Hallsberg. Hallsberg have good capacity, Malmö is a bottleneck. So when we should do our later demonstrations, then we focused on Malmö. And this is the Freight Rail 3 project with Trafikverket, research partners, and Indra have been involved. We started in, the project started in 2019, autumn, and we started with looking at Malmö, and up here is the arrival departure yard, and here is the main bottleneck where trains are going to and from. And then you have a marshalling part, and you have a combi terminal, MERTS. And what we were doing then was to having dialogue with dispatchers at Trafikverket, and then after that coming into this with the marshalling part and the combi terminal part. And then together with Indra developed this cooperative planning tool. And we then have started education of one expert user at the Trafikverket, one expert user at MERT's combi terminal, and one expert user for the marshalling part at the Green Cargo. And for the moment, we are in the latest part. So now we are doing demonstration and test the concept, and also prepare for next Europe Rail program. And this slide shows to the upper left is the yellow part here is the arrival departure part, controlled by Trafikverket dispatcher. And then you have this terminal manager, MERTS, and the marshalling part, Green Cargo. And what then have been made is this with a decision support that you see to the lower right, and to the upper right is the process, how Trafikverket dispatcher, planning person at terminal manager, and marshalling part, how they can communicate with this tool. And this tool will now be, we will do our first simulation. We will do it for a 2-day workshop with these actors. And then we will do it for 3 scenarios, one with a good day, one with a normal day, and then one with a bad day when we have generated infra disturbance. And we do it for a simulated data set. So it's not real-time online simulation. It's for a simulated test case that we are doing this. This is my last slide, and this is in some way to see what will be the next step. And to the right, we in some way see how what we are doing in Malmö connects to another national project at the Trafikverket that is run by RISE with the yard CDM. And there they doing these with collecting the actors that are active in yards, and then having these maps with the timestamps about the actors involved in yards can then send information how far they have come in these processes. And anyway, we see that these maps with the timestamps is a very good input possibility to this yard coordination system concept. So we think there are future possibilities in this area. For the left part, you can see what we are, the work in flagship 1 for traffic control in Trafikverket focus on this. And there we have identified 3 areas. The first area is that we have full scale demonstrations, and there we have a cooperation with GBS TTT. And there we have this controlled by planning and TMS and connected DAS. and so that is one area for having developed these methods and develop competence for connected DAS in Sweden and in Europe. And then the other part is this with nodes and network. And for nodes and network, we are, of course, where we have come longest is this with Malmö. The area 2 is what we are looking at, the future processes for TMS connected DAS and the next step ATO, and also for TMS, ERTMS. So we are looking for the future capacity planning processes and future control. In 2B, we are more, 2A is more wider, and 2B, we are more into simulation model and methods, and working with these models and method and decision support, and working with the capacity effects. Area number 3 is capacity planning. And there we have one part with the cross-border and this new TTR process, and the other part is nodes and network planning. And that was my presentation.
Thank you, Magnus, for this great presentation, and we look forward to see what will be the next generation time planning and yard management. I think we have to move on to the next presentation, but I think you were not able to participate in the Q&A later on, but if we get any questions, we will send them to you and send out the responses to the audience. So thank you. And now we will look into the new wagon concepts, and Arne Henning from the German Aerospace Center, DLR, will present.
Yes. Thank you very much. Sorry for that. Thank you for the invitation. Yeah, my name is Arne Henning from the German Aerospace Center. German Aerospace Center is a large research institute in Germany. There are more than 10,000 people working there, and they are doing almost everything, let's say. And there's an Institute for Aerodynamics and Flow Technology where I'm working on, which is dealing with aerodynamics mainly, and also acoustics. And in this institute, there's a department which deals with ground vehicles. That's what I'm working on. So I know that I was invited to talk about probably wagon concepts in general, but I have to admit I will hijack this talk here, talk more about the aerodynamic concepts we are developing here. So I'm really happy to be at least virtually in Chalmers again. I did my master's thesis there on my master studies, so it was a real pleasure. I think it was the greatest study experience I had in my career. So great to be there again, at least virtually. So let me see. So why are we dealing with the aerodynamics of freight trains, you may ask? There are two main reasons. First, it's the safety. Still, by strong winds, containers are falling off the trains, not regularly, but once in a year, twice in a year this happens. So if you're lucky, they're just falling off the bridge into the ocean. If you're not lucky, they're hitting other trains and there are casualties. So this is a real issue. And the second reason why we are doing is of course energy saving. If you look, this is a result from a study in the US. Of course, the wagons are a bit different there, but the main issue remains the same, that at a certain speed, and if you're talking about higher speeds, especially maybe in the future, the air resistance plays a major role. And therefore, we think it's important to also deal with aerodynamics for freight trains. So of course, this is first, it's the wagon itself where the aerodynamics is important, but also like the, let's say in which order you place this containers, for example, on wagons play a major role for the aerodynamics. So mainly we are tackling this problem with three different approaches. So first, we are focusing on wind tunnel measurements. So we take a wind tunnel where we produce wind, we put a wind tunnel model into this wind tunnel, and then we measure there the forces acting on the wagons, acting on the model, and try to improve the aerodynamics by this. Secondly, you can do computational fluid dynamics, which is called CFD, where you can have a more detailed look into the airflow around a train, around a container wagon in general. The good thing with CFD is that you get really detailed impressions about the airflow around the train itself. The drawback of CFD a bit is that you still have to solve the equations of fluid dynamics, which has a closure problem. So you have more variables than equations. So you have to model it. So you need to know a lot of details about the fluid dynamics in general. And sometimes this results are not fully reliable. The third one is what we are doing is our full-scale measurements. So in order to calibrate or validate our wind tunnel measurements and also the CFD results, we need results from real world. And that's why you're doing measurements at full scale, which is, of course, quite expensive, but the data you are capturing with this are of high value. So let me first show some results or some measurements we did at wind tunnel. So this is the wind tunnel we have here. So the wind tunnel, the air flowing is going around here. And there's a test section where you do then the actual measurements, where you place your model. In this case, if you have like ground-based vehicles, like we have in our case, then you also need, which is called a moving belt. The reason for this is that, of course, in comparison to an airplane which flies through the air, the ground-based vehicle is, of course, moving above the ground. So there's a relative movement of the model to the ground, and that's if you have a wind tunnel where you run the wind and the model is at rest, you also need to move the ground, and that's done by such a moving belt, which you have there in the test section. Of course, at the same time, you have to place somehow your model or mount your model, for example, by a sting, because you cannot put it on the ground because, yeah, there's the moving belt, right? So we did some tests. In this case, we were focusing on the wagon itself. So it's a flat wagon where a container is put on top, and we are aiming to optimize the wagon itself, which you can see here. So we tested different configurations. So here on the left side, you see our reference configuration for a 2-axle wagon. It's not a fully realistic wagon, but it has the main features of a wagon. So it has like axles, and it has this side skirts here and a little tanks for air pressure. And this wagon, if you put it in a wind tunnel like this, has a so-called drag coefficient of 0.89. You don't need to know exactly what the drag coefficient is, but let's say a very nice car, a modern car, has a drag coefficient of 0.2, and for example, the cylinder or something really draggy has a drag coefficient of 1. So this is somehow the range, and the lower you are, the better you are. So if you want to choose an optimal configuration like this, then you achieve a drag coefficient of 0.083. Of course, this is a completely non-realistic wagon. It doesn't have any axles and doesn't have any wheels, so it won't drive. But this is probably the optimum you could get if you imagine a wagon without any wheels. But if you put like more realistic configuration, like putting wheels and putting also like the skirts, we just by covering this lower surface, we got an improvement here to 0.175. You could go further and put like this aerodynamic optimized side skirts here. You're reaching 0.16. And you would imagine, okay, why not cover the complete wagon? Well, the problem is then if you do this complete coverage, you have a so-called blockage of the air, and by this you're increasing your drag coefficient. So you need to find the optimum way. And in this case, the most promising configuration was something like this, where we have not such a big coverage, not a big fairings, but we have fairings more or less all around the wagon, and have there the smooth transition from the front area to the lower area of the wagon, and we're achieving a drag coefficient of 0.139, which is already very good. And by this achievement, if you would improve a freight wagon by this, you could definitely save millions of euros by just the energy savings. And Another configuration I want to show, by just leaving out the axles here in between the wheels, you already get a really great improvement. But of course, at the current stage, let's say, a wagon without axles is not in the scope, at least not in the scope of the project we are talking here. A second part of the investigations is which we are calling boundary layer simulation. So if a train of a certain length is running through the air, there's a layer of air which is accelerated with the train itself, and then there is a so-called boundary layer, aerodynamic boundary layer. So this is the transition of the moving wind with the train, of the resting air, and this becomes rather big at long trains. And of course, you cannot put really such a long train model into the wind tunnel. So what you want to do is you want to thicken the boundary layer artificially by such, for example, here we did like spires, and also for the lower boundary layer, we put like Lego bricks on top of it in order to get a thick boundary layer at a short distance from the train head in the wind tunnel model. So here you can see some of this sample results. So if you have no tripping, you have and this is the velocity of the air, you have this really thin boundary layer. And if you put the spires, you have a thicker boundary layer, you have a more realistic aerodynamic conditions in the wind tunnel. And third, I was talking about full-scale measurements. What we developed during our freight train investigations was a container which is equipped with pressure measurement, pressure tabs all around, so we can put this container on regular operations and measure then the pressure fluctuations and the forces on the container itself for real world conditions. So the container, as I said, the container is equipped with pressure tabs all around, and we have different rings where we can then determine the forces on the container. Additionally, this container has sensors all around. So it has like LiDAR sensor in order to measure the distance to the environment. It has thermal cameras in order also to observe the environment. For example, if you're entering a tunnel, or if you're on the bridge, or if you have a train crossing, to determine all this. It has accelerometers and barometer in order to measure also barometric pressures. And yeah, tons of sensors are included in there. It's fully remotely operatable. So we have a 4G connection to this. We can download the data. It has also solar panels on the roof. So if it's not completely dark winter, you can operate this container more or less for infinite time without even have to touch, without the need for touching it. These are sample results of this container. So here, this is the measured speed. Here's the entering into a tunnel. Of course, we don't have any GPS connection to the container in the tunnel itself, but you can also see how the LiDAR sensors are working, how they determine the distance to the environment. And here, the main features are the pressure fluctuations we are measuring there. This is just an example how the pressure behaves if you, for example, are entering a tunnel, exiting a tunnel, and if you are on the bridge, for example, and how their crosswind are influencing the train's aerodynamics. So that has been my talk already. So thank you very much. And I think if you have questions, the Q&A is just following, I guess. Thank you very much.
Thank you, Arne. And yes, the Q&A will start shortly, and I will wait with the questions until then. But so this was the final speaker of today, and it's clear that we have a lot of good solutions to bring forward the railway system. And next Tuesday, we will listen to more about what we will do in Europe's rail. And then Jan Bergstrand from Trafikverket will tell us a little bit more about the goal to achieve seamless operations within Europe's rail, and Constance Banholzer from ÖBB will tell us a little bit more about the full digital freight train. And also Björn Bryne from the Norwegian Rail Directorate will tell us a bit about the Norwegian focus in Europe's rail. So that is to look forward for the next Tuesday. But now we will close this seminar and continue with the Q&A for those who have more questions. Thank you. Okay. Then we continue directly with the questions. And we have a few questions that come in. And first one to Arne. I think you had a question to Arne, Anders.
Yes, Arne, hello. I know that you are working hard to bring the core market wagon to Innotrans in Berlin this autumn, and I just wonder, can you tell me how is the preparations going? And
yeah, first, I mean, we are going to present the extended market wagon.
Extended, yes.
Wagon. Yeah, but yeah, it's going well. It's going really good. I mean, the construction is completed. We have now a company who's building the wagon. Of course, the DLR is not doing it by themselves, right? But yeah, we have a contractor who's willing to finish the wagon through the Innotrans. So yeah, we are on track, surprisingly somehow for me, because as you know, I mean, the DLR is not a wagon manufacturer, but yeah, the people did quite well. The wagon will have aerodynamic fairings as a result from this wind tunnel measurements we did.
Okay.
And it has like onboard units, automatic couplers. Yeah, it has a leveling of the wagon itself, so it can lower the height for the loading processes. And so it has a lot of great features. So we're looking forward to see it at the Innotrans, yeah.
You also have digital automatic couplers?
Yes, level 5.
Mm-hmm. Okay.
Yeah.
Looking forward to see that.
Yes.
And then we have a question to Andrea.
Yes, I have been working with you in this power peak shaving concepts. You only mentioned it very shortly when you started. Can you? What was the idea behind power peak shaving?
Yeah, do you hear me? The idea was to allow to reduce the overall energy consumption by lowering the power peak demands that a freight train has when traveling on a certain track. Some operators, some infrastructure operators, calculated the energy costs based on the peak demand that happened during a certain period of time that a customer required during a certain period of time. So what they're doing, they're looking at the whole the whole energy consumption of that specific customer, and they're just going to check where was the peak, and this peak gives them the price per kilowatt hour. And then you can imagine that if you are able to cut this peak, you can reduce the overall energy energy bill because the kilowatt hour price gets lower. And the idea of that was to analyze how can such a power peak shaving be implemented. And for instance, a locomotive with a last mile battery would be very well suited for that, because this battery can be used to provide the energy and the power in these peak phases, and this would limit, of course, the need from the catenary. And we have done some simulation. We've been looking also at a certain line in Sweden with the different substations. We were looking at how the freight trains are actually requesting power in looking at the different substations. And I think there was this very small graph on my slide on the right side that showed many small lines. These were power peak demands. And you could see that that there are few lines that are on top that surpass all the others, and these would then be the peaks that we would cut. The results are very promising, and this is something that the power industry, the networks usually do, but it's something that in railway applications has not yet arrived, and it will take some time to implement it because it needs to further analyze. Not all energy providers are calculating their costs that way, so we need to first understand how to implement it technically, and secondly then how does the business case work, and that may not be the case in all countries. For instance, in Italy, the energy price is always the same. It doesn't matter how much peaks, how big the peak is that you're requesting for.
Okay. Thank you.
Thank you. And you talked also a little bit about the long trains.
Yeah.
What do you see is the biggest challenge to implement these longer trains?
Well, there is of course, the infrastructure. I mean, there is a clear challenge, which is the infrastructure. To allow to run longer trains, you need to adapt the infrastructure. And you need to provide also, how do you call that in English? The freight trains are sharing the tracks with passenger operation, and passenger trains run usually faster, and that's why you need to provide an additional track to make the passenger trains surpassing the freight trains. So, like on these lines, the freight trains usually run at slower speed and allow the freight train to pass. So this is one thing, and you can imagine, of course, adding additional tracks on existing lines is not something you do easily, and it will also require a lot of money. And then there are, from a train protection perspective, there are some challenges. You have today axle counters that are too close to each other, so you would need to remove them or some of them at least to allow to allow longer trains. And also the shunting areas today are not fit for the purpose. There are just a few shunting areas that allow to compose a train that is longer than a kilometer. You can imagine how long these shunting areas must be, which means that you need then to think about other ways to create such a train, maybe then on the main line. So you have two short trains that somewhere on the main line get connected to each other. And this is, of course, not feasible with the hooks today. Maybe later on with the digital automatic coupling could be an option. I don't know. It's something that Europe's Rail is for sure going to look at. So it's not really a virtual coupling, but something that gets close to virtual coupling on a moving train. I don't know if this is going to be reality in the next decades. I would challenge that.
We shall see, and hope it succeeds. Sure. And I think we have one last question to Arne also. If you, Arne, could elaborate a little bit about how you will proceed on your work with the aerodynamics for the freight trains.
Yes, I mean, first, what we I think we have a great concept for the wagon itself, for an underbody. I think it will be a great improvement. One of the next steps is really to provide more exact equations for connecting the loading scheme to the energy consumptions, because what we are dealing now, all the equations you have at hand are from studies from the 80s, where they did aerodynamic studies on freight wagons, which had a completely different purpose. It was for this rolling hills, where the wagons are rolling down the hill. There they wanted to determine how fast it goes at certain wind conditions, to make sure that it goes far enough to be coupled then on this down. I don't know how this downhill things are. Abrollberg in Germany. However, and this were completely different Reynolds numbers and completely different conditions, and we really want to improve this by giving people a tool at hand to improve the loading scheme and to derive how much energy I can save if I have less gaps between the containers, let's say.
Yeah. And I think we also had one more question from the chat. Are the speeds too low, or could you in certain areas create aerodynamic lift to decrease the weight or resistance to have active aero depending on wind speeds or uphill downhill environments?
To decrease the weight. Well, I don't know if I understand the. Okay, increasing lift to the question is this won't work. Definitely not, because whenever you produce lift, you have a so-called induced aerodynamic drag. So there is no way to decrease the weight in order, for example, to decrease the rolling resistance. I think this is the way that this question goes. But the penalty for aerodynamics will always higher than the gain for the rolling resistance, let's say. So no, I mean you really want to have zero lift, let's say. Yeah.
Okay, thank you. I think that was all the questions for now, and it's almost 1:15. So thank you, Andrea and Arne, for staying in the Q&A, and thank you to all the audience who listened. And see you next week.
Bye bye.
Thank you very much. Bye bye.
Thank you. Bye bye.
Bye bye. Bye bye.